Hi everyone, today I'm going to work through question 2 from the 2017 Vcaa exam 2, so the extended response with CAS. So this is the Ferris wheel question that a few of you have been asking about. So let's see, Sammy visits a giant's Ferris wheel. He enters a capsule on the Ferris wheel from a platform above the ground. So here's the platform above the ground. I'll use a different colour. And the Ferris wheel is going anti-clockwise. The capsule is attached to the Ferris wheel at point P. So here's point P, and the height above the ground, h, is modelled by this equation here, where t is the time in minutes after he enters the capsule and h is measured in metres. Okay, Sammy exits the capsule after one complete rotation. So after one complete rotation, it means we've just got one cycle of the graph. So speaking of graphs, it's a good idea to draw the graph. And you can just do this on CAS, but I'm going to do it by hand. So our if we did not have that part, it would be 55 to negative 55, and the middle would be 0. Because we're going up by 65 units, we're adding 65 to each of those. So that means our new maximum height would be 120. The new middle part, 0 plus 65 will be 65. And of course, negative 55 plus 65 is 10. So this is a negative cost graph, so we will look like this. And then the only other thing that we should probably put is the period. So the period, of course, is 2 pi divided by whatever's in front of the x, or t in this case. Keep, change, flip, that gives us 2 times 15, which is 30. So just from what I've drawn here, without even looking at the questions, I've got a lot of information. I can see that the highest point he reaches, which would be there, is 120 metres. The lowest point, so when he comes back down to the ground, he would be at, or the lowest point would be 10 metres. So now that we've got that, let's look at the questions. So state the minimum and maximum heights of P above the ground. So there you go. We can read that straight from the graph. It's worth 1 mark, so we don't even need to show any working out. So the minimum equals 10 metres and maximum equals 120 metres. For how much time is he in the capsule? Well, we've also got that. That's the period of the function, so 30 minutes. Seems like a long time. Let's just double check. H is in metres and yeah, T is in minutes, so it's a long ride. Find the rate of change of h with respect to t, and hence state the value of t at which the rate of change is a maximum. Okay, so let's just not worry about the hence part yet. There's 2 marks, so excuse me, 1 mark for each part of the question. It's a bit overwhelming if you look at it all in one go. So the rate of change of h, well, that we're just going to find h dash of t, and we'll just use CAS. So I'm going to be doing this and dy dx of that of 65 minus 55 cos pi x on 15, is that it? Yep. So make sure you put it in right, because otherwise, of course, a lot of your answers will end up wrong. So let's do that. Okay, so I'm getting 11 pi on 3 sine pi t on 15. So this is my h dash of t function. Now notice when you see it on CAS, it looks a little different to that. My CAS gave me 11 sine pi t on 15 pi on 3, but look, I've neatened that up so it's nicer to look at there. That's what I'll use for my h dash of t. Now let's see what they ask for next, and hence state the value of t at which the rate of change of h is a maximum. Now look at the wording here, the rate of change of h is a maximum. So we've got 2 options here. It's not saying where h is a maximum, so it's not h dash of t equals 0. That will give us the maximum of of the h graph. We're not looking for the maximum of the h graph. We're looking at the maximum of h dash of t. So the maximum of this. So I mean, you could draw this on CAS, draw this function on CAS, and you're going to get a sine graph, some sort of sine graph, and then that's the maximum there. So you could do it as that, but it doesn't ask us for decimals. So look, it could be that it's an exact value, but it may not be. So look, I'm going to use the double derivative. And using the double derivative, I have d2 y over dx on my CAS. So actually, I'll just write that over here because I don't need that in my answer. dy over dx, whoops. And I'm putting in 11 pi on 3 sine pi x on 15. So I'm going to get d2y on dx equals 11 pi squared on 45 cos pi x on 15. Whoops. So I'm finding the maximum of the derivative function. So I need to derive the derivative function and then I will equate that to 0. So it's my double derivative. And now I can equate that to 0 for a maximum. And I am going to say, so 11 pi squared on 45 cos pi x on 15 equals 0. And then look, I'm going to put a restriction in. So 0x up to 30, comma x. And when I press enter, let's have a look. I get 15 on 2. So this means my t value is 7.5. So actually, if I would have used the graph of the sine function, of this sine function, the h dash of t, it would have been fine because it is an exact value. So my value of t, t equals what was it, 7.5? And that will be my solution there. So minutes, I'll put the units there as well. Okay, so be careful, the rate of change being a maximum there, it doesn't say the original function is a maximum, it's saying that h dash of t is a maximum. Okay, as the Ferris wheel rotates, a stationary boat at B on a nearby river first becomes visible at point P. Okay, so let's see, where's that? So it must be here. So when you're there, you can see this boat over here. So here's a boat, and as you're going on the Ferris wheel, you see the boat at that point. All right. B is 500 meters horizontally from the vertical axis through which the center of the Ferris wheel and angle CBO, that's that angle there, equals theta as shown. So I'll get rid of that boat there. All right. So find theta in degrees, correct to 2 decimal places. Now it's only worth 1 mark, so it can't be too much working here. So let's see, what have we got? We know that this length here, that was 65 from, well, let's look back up. So we know that from our graph, or from our equation, that's 65 there. So here's 65. We also know obviously that this is 500. So that's actually pretty easy. We can solve for theta. It's just using trig. Let's label the triangle H, O, and A. So SOHCAHTOA, this involves using tan. So tan theta equals O over A. So 65 on 500. And let's see, we've got to do inverse. So on my CAS, I'm writing, theta equals, so tan inverse of 65 over 500. So I'll just quickly do that. Tan inverse (65 over 500). Right, and I am getting, let's decimalize that. Oh, I was in radians, I must turn that into degrees. So I'll redo that, change it into degrees. And I'm getting 7.40691, blah, blah, blah. They want it to 2 decimal places. So it's 1 mark. I don't even need to show how I got it. can if I want. So theta equals 7.41 degrees. So there's our solution there to 2 decimal places. Okay, so what I'm going to do, I'm just going to put that in so that if I need it later, it's already there. So theta equals 7.41 degrees. There we go. Okay, next, part of the path of P is given by y, where x and y are in meters. Okay, find dy dx. So that's pretty straightforward. We can do it directly into CAS. So dy dx equals okay, so I'm getting negative x on root 3025 minus x squared. Just make sure that you use the correct variable. In this case, it is x, but sometimes, they might put a different variable and then, you've written x, so that's not correct. Watch out for that. Okay, there's our derivative. Okay, as the Ferris wheel continues to rotate, the boat at B, so remember this was the boat here, is no longer visible from point P2. Okay, so let's just think for a second. We had a point that I think we called P1, yes. So here was P1, and this is when you could see the boat. Oh, look, there's a boat just over there. You can see it there. And as you go on the Ferris wheel, you keep going this way anti-clockwise, remember? And then you get to P2, and then you can't see the boat anymore. So it must be that when you look from here, you sort of see, I don't know, somewhere that you can't view the boat for whatever reason. The line through B and P2, so that's this line here, is a tangent to the path of P, where angle OBP2 equals alpha. Okay, OBP2, so this angle here is alpha. It's just pretty much just exactly what they're saying. So what do they want us to do? Find the gradient of the line segment P2B in terms of u, and hence find the coordinates of P2 correct to 2 decimal places. Okay, well, let's cross out the second part. Find the gradient of the line segment P2B in terms of u. So let's just ignore that for the minute so we don't get overwhelmed. It is worth 3 marks, so it's a little bit more involved. Don't want to leave it blank. So what have we got? We've got the derivative. So the derivative of the path of y, so that will be the gradient of the tangent at whatever point. So let's write that down. So P2 is going to be, well, actually, I'll write the gradient function. Well, no, we can probably just see it there. I'll make it smaller if we need it. So P2, let's label this point. The V value for when u is the point, it's going to be the y value of whenever we have a u. So our equation, let's head back up. The path of P is given by this. So this is the path of P. So this is how P goes around the circle here. So any point on that circle, if you've got the x value, you can sub in to find the corresponding y value of that point. So we have u as our x value. So this point must be u, comma, root 3025 minus u squared plus 65. So that's what I'll call that point. So we don't have a nice value, but we have it in terms of u. So I'll just write that here. P2 equals u, comma, root 3025 minus u squared plus 65. Okay. Now, what do we know? We know the gradient. So from part E. So actually, I will actually put that there. Dy dx will equals neg x over root 3025 minus x squared. Okay, so that's our gradient function. We'll use that in a minute. What else do we know? Well, we know the point B. We can deduce the point B. Look at that, we start at 0. This is 500. and then it's on the axis, so it must be that the y value is 0. So the point B is 500, 0. Okay, so now that we've got that, we can say, well, the gradient of our P2 to B, so this green line here, so that tangent, so the gradient of P2B equals, well, y2 minus y1 over x2 minus x1. And let's just do it. So now we can say y2 x2 x1 y1. And I've purposely made the more sort of convoluted point, i.e. this one here, I've made that number 2, because then I cannot have as many negatives. So root 3025 minus u squared plus 65 minus 0, so I won't write the minus 0 in, over x2 minus x1, so that's u minus 500. All right, so this is a gradient equation here. So we have, find the gradient of the line segment P2B in terms of u. Okay, so we've got this. That's the gradient of the line segment. So we've used y2 minus y1. Here they're saying to us, and hence find the coordinates of P2. So we want to know what u equals, and hence then what the y value, or v, I think that, yes, it was v. We want to know what that point is, and we want to get some sort of value for that. So let's see, we've got 2 equations for gradient, and well, this is simultaneous. So I can say root 3025 minus u squared plus 65 over u minus 500 equals negative x over root 3025 minus x squared. So, and I actually should make them, if I'm putting into CAS, of course I'm going to put x, but look, for the sake of my showing my working out, I might just leave it as u, because that's what we're trying to find. So if I solve that on CAS, which I will do, so of course what I'm doing here, and I wouldn't write this in my working out, but I'm using solve and comma x, and the u's will be x's there. So you don't write CAS notation there. Let's do that. It's still thinking. Alrighty, so I'm getting u, or x, on my CAS, but obviously we're referring to u, 12.9974821, and we want to 2 decimal places, but when I sub that in, I would use my full value of u. So let's sub that in. So v is going to be my y value. So I will say v equals, so I'm subbing it into my y function there. Let's do that. Okay, so my v value, 118, whoops, what's going on, 118.44. So let's have a look. This u value, we're doing to 2 decimal places now. So I've found the gradient of the line segment. Here it is. And then my point, coordinates of the point P2, so I'm kind of running out of room here a little bit. So P2 is just going to be the points, or 12.997, that's going to round up to 13. Make sure you write 13.00 because, well, you need 2 decimal places. And then, of course, 118.44. So look, I've got more working out than what I need to show, but hopefully that makes sense how I have achieved those things there. All right, let's move on. So the next part, they are asking us to find alpha in degrees correct to 2 decimal places. Okay, let's think. So Alpha, what is alpha? Okay, alpha is here. And remember that to find a gradient, well, we can go tan theta equals the gradient. And in our case, we're looking at alpha, tan alpha equals the gradient. And our gradient we had was x on 3025 minus x squared. And then, well, we can do the inverse of that. So remember that we've used u, and at u, we're finding it at u, so I can sub in 12.99748021 squared. I'm just going to write 13 here, just, to save space. And then, well, now my alpha value, alpha is going, what I write into CAS is the tan inverse of that. So 30 root 3025 minus 13 squared. And then I'm going to get, let's have a look. By the way, we don't need to write all this. It's just to show you the working out there. It's only 1 mark. So tan theta equals the gradient, or tan alpha in this case. So, okay, now make sure we're in degrees. Otherwise you'll get something weird there. And I'm getting 13.67048021. But of course, we want it to 2 decimal places. So it's 13.67 degrees. Okay. Hence or otherwise, find the length of the time to the nearest minute during which the boat at B is visible. Okay, so let's have a look. So where the boat is visible, let's just highlight it, is from here to here. As we said before, when you go beyond that, you can't see the boat, and before that, you can't see the boat. So it's just that blue sort of bit there. So let's see what we need to do. I'm going to stretch that line across there. We've got alpha, which we found a second ago, and alpha is this whole angle. So actually I'll do like this, and this is 13. What was alpha? Hold on. Alpha was 13.67 degrees. Okay. What else have we got? What we need here is this angle in here. Because, well, this is a sector of the circle. So if we can find the fraction of the circle and then times it by, well, 30 minutes, the whole time, then we're going to get the length of time that we have. So let's see, what I need is this angle in here. So I've got alpha. I might call this, we've already got a theta, which actually reminds me that theta is probably involved in this. So this angle here, I'll call it beta. So, and that's the angle we need to find. So theta, and if we look back, yeah, look at that, theta 7.41 is from the center to B, and that's exactly what we need. So there's the center, yeah, good, up to B. So this angle in here is theta. So if we want to find beta, beta is going to equal our alpha minus theta, and alpha is 13.67, and we're subtracting theta, which is 7.41. Okay, so let's find that. So beta equals, I better write here, alpha minus theta, 13.67 minus 7.41. Okay, and that equals, now just to note, I've used on my CAS, I'm just pasting on my CAS the whole values here. So actually what I'm putting into CAS is 13.67 66931,853 and subtracting 7.406912,128, because otherwise if I round too early, then my answer will not be correct. So I could be off by a couple of decimals. So what I get when I subtract that is 6.262406402. Now I'm not going to write all that there, so I'm just going to call it 6.26. So in other words, what I have now is the circle, and I have, you know, a point here to here or whatever it is, and that's where I can view the boat B. And now what I've worked out, here's a right angle, and what I've worked out is I've got this angle of 6.26. Now this is 90 degrees. What we want is this angle. So, well, let's call this, I know, star. So star equals 180 minus 90, which is 90. So 90 minus 6.262406402. So that star angle is, just cut and paste that there, or copy and paste it, and I'm getting 83.74 degrees. Now, so let's think what we've got. We've got this angle here, and that angle is a part of a whole circle. It's a part of 360 degrees. We want to know this, what this is. So we can do that by saying, well, 83.74 over 360, so that's the fraction of the entire circle. And well, now how long is it? Well, the whole circle takes 30 minutes. So it's that fraction of 30 minutes. And in maths, of means times, of course. So we times it by 30. So let's do that and then we should have the answer. Okay, so I'm getting 6.978, and that'll be in minutes. And look, we can work out the seconds by timesing that by 60, but I better read it. What does it say? Hence will otherwise find the length of time to the nearest minute. Actually, that's much easier. During which the boat at B is visible. Okay, so it must be 7 minutes. So we won't be timesing that by 60 at all. So boat is visible for 7 minutes. And that is that. So that completes, I think, yes, that completes the Ferris wheel question from the 2017 exam.